Hello, in this video we are going to demonstrate the simplest ever possible implementation of SPI communication, which is sending one value in the hexadecimal format from ESP32, which is defined as a slave, and to the Raspberry Pi 5, which is defined as a master. Inside the ESP32, we will work in the ESP-IDF5 environment, and inside the Raspberry Pi, we will write a simple Python code, and then we will demonstrate the message transcription. And those, I will enlarge it, like this. This is a setup of Raspberry Pi 5. Here you can see the pin numbers, which we will use those pins and where they are located, and also this one and the ground, and you will see it later. And also for the ESP32 we have the pink GPIO abbreviation of the numbers, so all the numbers is GPIO pink defined numbers. We will use those GPIO 12, 13, 14, and so on. To our connection, the MOSI master out slave in and MISO master in slave out are connected to each and add to one to the other, where MOSI, here we see this is a master, Raspberry Pi is defined as a master sending the message, and MISO, here ESP defined as a slave, is sending the message this way. And the Raspberry Pi have its external power up connection, and ESP32 is connected to the PC via the USB port, so we can see what is actually going on the serial screen. Now let's go to the code. Here inside the SIMS IoT devices, inside repositories, we have a FreeRTOS ESP-IDF SPI repository. Here we have different SPI communication examples, where specifically now we are talking on this number 4, example number 4, where ESP32 is connected to Raspberry Pi 5. And here you can see the two files that we are using. The first one is ESP32 slave transmit.c file, and the other one SPI Raspberry Pi 5 master receive Python file. So we will take this one and put it inside our editor, inside our new project that we have built, and we will take the other one. I will show you in just a moment, this one, and put it on this Raspberry Pi, and we will see how it will work on Raspberry Pi. So now we are on our PC, so we can see ESP32, which is connected to the PC computer. This is the code that we are copying and pasted in our project. We will run it. Okay. And this is the same code that we are usually using in different examples. Slave is here defined as a transmitter, so we have different includes. We defined here the pins. You see, MOSI is 12, MISO is 13, clock is 15, and chip select is 14. And it is very important, those are GPIOs, the pink ones, remember? Okay. We have a main function where first we define the SPI bus config, where we define those pins. Then we define this SPI communication mode and the chip select and so on. Here we initialize the SPI, and then we define one character, one value, hexadecimal value that we want to transmit. We want to transmit this value, okay? Okay. Now in the SPI slave transmit.c, we define the length and we initialize the data. We put the data here inside the buffer, and then we're transmitting it. We're transmitting the value and the print that we have transmitted the value. But please note that nothing is happening because the master, the Raspberry Pi 5, didn't initiate a communication and didn't send us any data. So what I'm doing, I'm going to the second computer. You will see it in the moment. Okay, now we are on our Raspberry Pi 5 computer. What we see here is the standard Python code, which we can stop now, and the ESP is ready to transmit. In order to initiate the communication in SPI, the master, which is in this case this Raspberry Pi 5, have to send a value in order to receive a value. So how can we do it in this program? We import the SPI library. We define the basic SPI parameters, the SPI variable. We open the bus and define the speed and the mode. And then we send a value, in this case in the hexadecimal form. And after that, we receive a response, one value. So we will print it on the screen, and I will run it. And you see, this is the values that we have received. I can stop the program and run it again. And once again, this is the value we have received. Now I run the program on our second computer, and you see the value is transmitted. I will run it once again. The second time, the second value is transmitted, and the last time I'm running the program on the Raspberry Pi. The program is sending to us a value, and so we are transmitting the value to the master. So what we have seen here is a communication between Raspberry Pi 5 defined as the master to the ESP32 defined as the slave, where ESP is sending a value to the Raspberry Pi in the simplest possible fashion. Thank you.